Hi guys, welcome back to my channel. Myself Bharatji. Today I am here with a small topic stack operations from data structures and analytics. In this video we are going to know about introduction about stack operations, pop, push and peek operations of stack, implementation of stack, applications of stack and complexity of stacks versus queue, and at the end conclusion about stacks. Let us move into the video. For the beginning, introduction to stack operations. Stack operations are the fundamental structures of data structure and science. A stack operation linear data structure that follows the LIFO, last in first out principle. LIFO is the main principle where stacks works under. The main operation performed in stacks are pop, push and peek operations. Next, push operation. The push operation adds an element to the top of the stack. The main purpose of push operation is it adds an top element for the stack. The element is added to the top of the stack and becomes the new top element. When the element is added to the stack, it becomes the new top element of the push operation. Pushing an element onto a pull stack will result in an overflow condition. This pushing operation results in the overflow condition of stacks. Next, pop operation. The pop operation removes the top element from the stack. The main purpose of a pop operation is it removes the topmost element from the stack. The top element is removed and the next element becomes the new top element. When the top element is removed from the stack, the next elements become the new pop element to remove from the stack. Popping an element from an empty stack will result in an underflow condition. This pop operation results under an underflow condition. Peek operation. The peek operation allows you to view the top element of stack without removing it. This peek operation helps us to view the topmost element of the stack without removing any element from the stacks. The peek operation does not modify the stack in any way. It does not modify the stacks in any other ways. It is useful when you need to access the top element without altering the stack. It is very essential when we used to alter the stack elements without removing or adding them to the stacks. Stack implementation. Stacks can be implemented using arrays or linked list. Array implementation provides constant time access to elements but as a fixed size. Arrays and linked lists are used to implement a stacks element, and array implementation provides a constant time access to the elements but as a fixed size. Linked list implementation allows for dynamic resigning but as an additional memory overhead. Linked list has an additional memory overhead and it allows us a dynamic resigning of stacks. Stack applications. Stacks are widely used in programming languages for function calls and recursions. Function calls and recursions are mainly focused under stack operations. Full stack development, they can be used for undo and redo functionalities in text editors or graphical applications. Undo and redo functionalities are used in text editions or graphical representation of stacks. Stacks are utilized in backtracking algorithms and solving problem involving depth first search. The stack applications are used in tracking back algorithms and solving the new problems depth with first in search. Time complexity of stack operations. The push and pop operations have a time complexity of 0, 1 or constant time. The push and pop operations have a time complexity of constant time. The peek operation also has a time complexity of 0, 1. This constant time complexity makes stacks efficient for many applications. Stack versus queue. Stacks and queues are both linear data structures but different in order of element removal. The stacks and queues are both are similar to linear data structures but different in order of element removed from the stacks. Stack follows left in and first out, while queue follows first in and first out. Principles. Stacks are useful when order does not matter, whereas queue maintains order. Stacks are useful when the order does not matter which element to be removed from the stacks. It does not matter in stacks, but queue maintains the order when which element to be removed from the stack first. Then Conclusion: stack operations include push, pop, and peek are essential in computer science. Push, pop, and peek operations very essential in computer science languages. Stacks follows the left in and first out principle and are efficient for many applications. Stack follows in a LIFO principle and efficient for many applications. Understanding stack operations and their implementations is crucial for designing efficient algorithms and data structures. Understanding stack operations properly and implementing crucial designs, efficient and algorithms and data structures is main applications of stacks. Thank you for watching my video. Please like, share and subscribe.